afternoon, everyone, and thank you for being late for us here for our project. We got lucky to be the last presenters, which is a good thing, right, for all the team. Well, let me get to the point. This project is what we call here Embry-Riddle Biodiesel Reactor Project. The project is consisting of two parts. The first part is taking the waste oil, vegetable oil, from anywhere, restaurants or anywhere, mix it chemically, and then pass it through biodiesel reactor to have a biodiesel. Ready to be used, let's say, for specific kind of applications, not high-grade kind of biodiesel, but it can be made better grade. This is the first project of the biodiesel at Embry-Riddle. In the future, we were thinking to extend this project, to extend the objectives, to work on maybe producing some kind of GP 5 or 8 kind of fuel, jet fuel for aviation. But that is a task that needs some research and needs a lot of help. The team did a very great job in completing the project. We got to the point where we tested, the team tested the project, and they're going to show you 1 to 2 minutes video about the test with water. We could not test with oil because of the safety issues. However, in the future, once those safety issues resolve, we'll be able to test with oil. So I leave the presentation for the team. They can introduce themselves and we'll listen to what they have. Thank you.
All right. Hello, everyone. Thanks for being here. We are the Embry-Riddle Biodiesel Reactor Group, and I'm William Watlett, the design team lead. This is Gabriel Kutowski, Brian Rhodes, Caleb Seek, and Sophia Newton. And before we continue with the slides, we'd actually like to show you guys the video first. So Brian's going to take that away and he's going to describe what's going on. Pardon the wait time. Just got it. Yeah, it happens.
So what we're doing here is our initial leak test, and this is the bottom section of the reactor where all of our products will be entering into the reactor itself. So through the shower head, which is our diffuser to help get a good mixture throughout the entire reactor. As we move around here, we can see the pumps where the methanol in the top left are. That's where the pumps where we'll pump in the used vegetable oil and the triglycerides. And here's a good view of the system for our storage tanks. The triglycerides would be on the left, the methoxide will be on the right. And it's a complete water test, so we filled the system and checked all seals and all connections for leaks over about a half-hour time frame while it took to fill the reactor and then flow some liquid out. And we'll continue on with the presentation.
Thanks, Brian. All right, so a basic overview of what we're going to go over today is we're going to start with the chemistry, like how is biodiesel made? And we're going to go through all the little nuances of that. We're then going to talk about test mixing, because we tested and mixed some methoxide to prove whether or not it was safe or not to do so. Then Gabe's going to talk about some static mixers that we implemented in our process. Then we're going to talk about the design specifications, which include the actual design itself, the fabrication of which, and then the plumbing specifications. After that, Caleb's going to talk about the data acquisition, Sophia will talk about the safety, and then we'll add some recommendations and then conclude the project. So, with that said, our purpose and objective of this project was to create a continuous flow biodiesel reactor that could create biodiesel at about 0.64 gallons per minute. Now, for detail, we wanted to actually fabricate the reactor and test it with water before we actually did anything. So let's talk about chemistry.